So I'll be talking not pretty much about iOS, but a little bit more about Amazon Web Services. So that's why I first want to poll a little bit your experiences. So who here has done some server work or is doing it regularly or once in a while? Some hands? All right, it's not too many people, so a lot of iOS. And who is using Amazon Web Services or has used it? All right. Well, almost more than people that do server work, I guess.
I use it from the client side or use it as a server?
Well, okay, that's good. So, and API Gateway, Amazon Lambda, any experience with that? All right, 2 people or 3, good. So I'll be talking mostly about those 2, and then I'll show how you can generate some iOS Swift code from that, and then how you can, well, of course, easily invoke your API. But first, a little bit about where I work. I currently work at Nyon, which is one of our sponsors, also from CocoaHeads. What we do there is we build an iPad app and a platform for retailers, mainly in the fashion and the shoes, to do their purchasing at suppliers. So they enter all the orders in our app. And well, I'm not going to talk more about that, but our stack, it's a pretty big stack. On the iPad app, of course, we use Swift and Objective-C, more and more Swift. Right now, we're about 50-50, so it's a nice mess. And on the server, it's a lot of Python microservices. We have about, I think, 10 different microservices. They're all Django applications. On the web, we do a lot of AngularJS. Well, we used to do AngularJS, and right now, the new stuff we're writing in React. And then we have a lot of AWS services that we use, about, I think, 15 different services now. And, well, I'm pretty much a full-stack developer. I do all of it. I think, like, right now, only about 25% iOS, a lot of backend, and also a lot of React. So it's a nice experience to do everything at the same time, but it's also a little bit chaotic. So today, API Gateway. And first, why would you want to use the API Gateway instead of writing maybe your own API, like in Node or Java or whatever? Or if you're, of course, an iOS developer, you probably often use APIs, maybe Twitter API, Facebook API, or a weather API, or some kind of other API. And you can use those APIs directly, but you can also put an API gateway in between so that your app only uses your API from the API gateway, which then proxies other services and your own servers. So you only need to talk to one API, basically. And if some third-party API goes down, then you still can do other stuff and make sure that you don't get unexpected error codes, or if they change stuff, then you actually are in control. So that's pretty nice, and it gives you a lot of flexibility. So small overview of what it looks like. You see here the iOS app talking to the API gateway. So that's just a REST API, as you would expect. Normal resources, normal get, put, post methods, and so on. But behind that gateway, there can be all kind of different stuff, basically. You can just proxy to other APIs, third-party APIs. I'll show that in a bit, where I do a call to like the GitHub status API just to get a response from there through the API gateway. Also, one of the things that I will be talking a lot more is to do Lambda calls. So you use AWS Lambda. And Lambda is a serverless architecture. So instead of having a server that's running all the time, you just basically write small functions in either JavaScript or Java or Python, and there are a bunch of different options there. And those functions, they are not actually alive, but until they need to run, at that moment, they're bootstrapped basically, and they'll run for you, which makes it flexible, of course. When no one is using your app, nothing is running. And when all of a sudden like 100,000 users are using your app, well, all those 100,000 functions will just run. So it can also be very cost effective. And those Lambda functions, they are very flexible. You can integrate them with other Amazon services. Like you see here, you can call your servers on EC2 instances, which are like more traditional servers, like a Linux machine that's just running a Java application or whatever application. But you can also easily call like a Elasticsearch service, which we do a lot at Nyon. So I'll also show a little bit about that later. And you can also actually trigger stuff with CloudWatch events. So those are events you schedule, you say like every 5 minutes or when something happens or every hour. And then invoke Lambda. And also with Lambda, you can call another Amazon service, which is called SNS, Simple Notification Service, which you can actually use to automatically send push notifications. So you configure a bunch of things there, like your certificates, and then you can use it to do push notification, which of course for iOS developers is also pretty useful. So what I'm going to show you, the API that I will demo, is basically going to have these calls. So like I said, a direct call to the GitHub status API. And that's, so these on the left side, they're all endpoints in my REST API that you'll see that I can call from the app. So the first one is going directly to the GitHub API, no Lambda function in between. I also wrote a small Lambda function to get a status from a RSS feed from Amazon themselves. So this is kind of the example where you would be maybe calling a weather API, but you don't trust it or maybe it changed, so you write a small Lambda function in between to call it and to make your own response. And this one is going to be an endpoint that actually calls into our Elasticsearch instance. And you see here a VPC. So the VPC, that's the virtual private cloud of Amazon, which it's like a network within Amazon that you cannot access indirect means. So you can have services running there that are not publicly accessible. So that's of course good for security. And it's also easy for mocking. Like maybe you need to do iOS work, but you don't have the server yet. Maybe other people are writing the server, and you're waiting for them. So often you need to mock things. And the API gateway actually allows you to already finish your API, just put some mock responses in there, build your entire application, and then later on you connect it with the actual backend. So how do you create an API? So you need to see the API gateway as a way that you create the entire API, every endpoint, but also all the responses. You define it very precisely, everything it can do. Also, if you do that, you'll never have any unexpected responses from your API. Like if you would call into some random API, you might get strange JSON responses that you don't expect in a different format, or you might get a 500 response error or a 404, something doesn't exist. So with the API gateway, you narrow it down so that you pretty much never get anything that you didn't configure yourself. So all the responses, the models, you configure everything. So you first create resources like /order or /order/ID. Then you create the methods that are possible on those resources. And then you define the models of the things that it can return. And you also define custom response codes. If you don't do that, everything will always return a 200 response code. Even if you would be calling like a third-party service, which would fail, then still it would just return a 200 code, because you need to configure actually a mapping from whatever your Lambda or third-party API returned to something else. An API method, it consists of 4 different things actually. So the client would first do a method request. So that allows you to inspect whatever the client is sending and to do transformations, or to say if it needs authentication or query parameters. Then you have the integration request. There you decide, what do I want to do with it? Do I want to call Lambda function or just proxy it to another HTTP function? And when you get the response from whatever it is you're calling, you can also, again, map that to something else, or just return it like that. So that's the integration response. And then the method response, you can add extra headers and such to your response. And the last step about the API gateway that you need to do is deploying it somewhere. So you can have multiple stages, multiple versions. So you can have like a development stage or a production stage. You can add those to different domains. So you, for example, have a test.your domain or API.domain. And you can still develop your API while another version is in production, as you would kind of expect from such things. And then the client generation that I talked about. Amazon actually allows you to generate code from all these different languages, and AWS Swift is included there. But you can also generate a Swagger file, which is, I think, more interesting. And then you can generate like 50 different languages or something, a lot. A lot of things are supported by Swagger. So a little bit about the pros and cons, because when I played around with these, I ran into some trouble. So if you would use the SDK generation, then, which is actually using the Amazon libraries for talking to the gateway, but those are not really updated yet for Swift 4. You can get it a little bit to work, but also expect some crashes here and there, and you'll have to change the code a little bit. So I would not recommend, if you ever want to do this, to use that. Better way is just to get the Swagger file and generate code from that, which is also interesting if you would get a Swagger file from any other server. It would work exactly the same way, because the Swagger, it's not specific to the Amazon API gateway, but you can use it pretty much for any API, which makes it a lot easier often to talk to your APIs. So I just want to go ahead and show a couple of things.
Question.
Yeah.
The Swagger bit mentions missing some features. Could you give an example?
What do you mean exactly? Oh, on the slide. Yeah, I'll actually show that later. It's because the SDK generation, because it's using the SDK for the API gateway, you have things like setting an API key and other things that you can do directly with the API gateway. With the Swagger client, it's quite basic. You can do requests and everything, but it doesn't know really about things like an API key from the gateway. So you need to do a little bit more. Still, everything is possible, like setting headers, of course, the basic things that you would expect. And it's using Alarmifier under the hood, so you can do pretty much everything you can do with that. But like the features on top of it that might make it easier, it doesn't have that. So this is what it looks like. I don't know if you've ever worked or seen the AWS Console. So this is the console. You have all the different AWS services that you can use. Now, Amazon is not the best at UX design, so sometimes it's a little bit looking around like where things are, but it's doable. So I just want to add a new resource here. So this is my REST API as it currently is, and if I have time at the end, I can show some of these existing ones as well. But right now I'm just going to create a new one. And what this screen, is it okay if I zoom out a little bit? Is it still, can everyone still read it like this? Yeah, makes it a little bit easier for me. So let's say this is our internal resource, because these are external, the AWS, GitHub, etc. I'm going to make it internal, and you can nest things. So in here, I'm going to create another one, which I'm going to call services. And this is going to be a API call that checks if my like services, my service microservices basically in this case, are still healthy or not. You can also see here that this is the health API gateway. You can, of course, configure as many APIs as you want, the health API, to check if our services are healthy. So it's just going to have a single method, which is the get. And for now, I'm not going to connect it yet to any backend. I'm just going to use a mocked response. And then here, you can pretty much see the 4 boxes that you saw on my slide to configure everything. And this is the response. This is where you actually need to configure your mock. So you configure that it's returning the 200 response code. And well, there's a lot of searching and clicking where things are. That's what I mean with like their design. And I'm just going to copy paste my response in here, which is this one. So this is what I wanted to return. That service A is healthy and service B is unhealthy. So that's just JSON. I need to save here and I need to save here. And so right now, my Swagger wouldn't know yet from that piece of JSON what my response would look like. So therefore, I also need to configure a new model here. And I see I actually still have it here, so that's fine. So I created this one, and here I define very precisely exactly what my response would look like. So you see here an object that has the services property, which is an array that has the name and the status, which are both strings. And this one matches exactly with the JSON that we're going to return. So we also need to configure that we actually want to return that one. And you can do that in the response. So right now it goes to empty. That's the default. It's just an empty JSON response. I'm going to set it to the services. This one I don't need to save. And now, yes, question?
Is that checked by the Amazon thing that the service actually returns something of the correct model?
So you're asking if it's the JSON that you're mocking is according to the model?
Yeah, in this example, it's a mock, so it
Yeah.
something else.
Yeah, you can do a lot of things with that. You can add, I'm not sure if it's on this one or this one. I'm not sure if it's checked in that way. I think you just get an error. But in here, so this is just JSON. But in here, you can also write a little bit of code actually to map it to another model. So you can also validate it there. I don't know if you can actually build validators for the responses. Because in here, in the method request, you can, for the request that's incoming, you can add a validator there. But I don't know for the response.
But it will never respond with a thing that doesn't.
Exactly, it will only respond to the client, whatever is in the model.
Yeah, but then if you, like, if the service that you're calling, or if whatever code you use to generate the JSON, if it generates wrong JSON, it will just return error code to your client.
I don't know.
Instead of returning
It might still just return 200, but I don't know. So the next thing we need to do is actually deploy it. And for this, I created one stage, which is my testing stage. And I also have a domain for that. So if you look here in the custom domain names, you see health.fashionexchange.nl is actually, you see that here, going to that API. So if I now, oh, that's not what I want. If I would call this one internal, then you see the mocked response already. So that was pretty easy. Now for the code in the iOS app. And for that, I'm only going to show the Swagger, because as I said, the other one doesn't really work. I will show you where you can do it. So here in resources is where you create it. So that's what I just did. Now I'm going here into the stages, and that's what's already deployed. You see a very similar structure, but you cannot change anything here. And here in the stage itself, you have a couple of tabs. And here in the SDK generation, you can choose your platform, like I said, iOS, and then you generate it. It will just generate a zip file, and you basically copy that into your Xcode project, and then it works. With the Swagger generation, so export the Swagger. Then you have the Swagger file. You can see that here, and here you see the definition of the call, and you also see that it returns like the services model, which you can see here also defined. I'm going to use this one now to generate code. And let me just quickly copy it to the right folder. And let me see what it was called. Oh, testing. Number 6, which is going to then. Okay, so before I already had the project created, but it was using. Show you. So if you check the diff, you see that exactly that call was added there, and also the something else that I was working on today, which doesn't really matter. But oh, I thought I copy pasted. No, seems like I need to. Well, I lost my. Here it is. So this is the command I need to run. So the Swagger codegen, that's basically from, I don't know if it's a corporation or not, the Swagger, but that's the library that you can use to generate like all the different languages. So I specify here the input JSON, and I specify here the language that I want to use Swift for. So this will generate the whole new thing. And if you look in the project, it's actually both a pod and also there's a card file there, so you can install it both as a pod or as a cartridge library. For this case, I'm going to use the pod spec. Unfortunately, what it also does is it changes my pod spec because it's removing always 2 required ones. So I'm just going to undo that. And now I should be able to install it. So this is my actual project. I'm going to run pod install, which is using it from development. And then you can see the code. So this is the generated code. And this is readable. Good. So here you can see actually already the call. So it generates the calls both with request builder, and that one you can use to do set additional headers and so on. But it's also generating, oh, there it was. Another simple call that just you pass in a closure and you get the services object, so the model we defined back in case it succeeded or an error. So let's do that. And first let me just show you this little app, well, not on my phone. It's a very basic app that just uses the API for demo purposes. Let me, oh, that's a little bit small. Right, so this is the AWS endpoint that's doing the RSS feed, the GitHub API, and this is my own. Well, right now, of course, I didn't implement the code yet to actually do the function call. So I need to add that, which is quite easy. That's in here. So I did already write the handler to handle my response. So let me remove the comment. And here I can use the API. So I'm just going to do the internal call, pass in my handler. And that's interesting. All right. Right. There we go. Because later on I actually want to add the API key, so that's why I prepared it with the builder already. And now we can see service A is green, service B is not. Of course, we could change things and then you would see that it actually works, but I'll do that by actually wiring it to some existing code. So that's the API gateway. Let's go back to the presentation. So the next thing is AWS Lambda. And what I will do soon is, instead of the mock implementation, I'll actually call the Lambda function from the API gateway. So like I said, AWS Lambda, it's a serverless architecture. You just write the function and tell it how to run, in which environment a little bit, and it will just run whenever it needs to. And it can run either outside or inside a virtual private cloud. If it's outside, it means it doesn't really have access to your resources inside the VPC, but it can do calls to external, like third-party APIs. If it's inside, it can access your internal service, but it cannot do calls to the internet. So it's really inside. You can make it do calls to the internet, but you need to add other gateways, like an internet or network gateway from your VPC to the outside world. So it's built for security in that way. Also has security policies, but not going into that. And like I said, these are the support languages. Unfortunately, we cannot use Swift in Lambda functions. Hopefully they will add that one day. So my preferred choice here is always Node, so that's JavaScript. So the way you can imagine Lambda is just a lot of functions. If you have a huge server, basically, it would also require you to have a lot of Lambda functions that can do calls to all your different Amazon services. But let's also just go into that and show it. So very similar as the API gateway, this is the Lambda Console. Here I also just going to create a new function. Amazon provided a lot of blueprints that you can choose from that is basically just sample code that you can then change. They also already contain policies to, for example, read from your S3 or write to your database, such things. I'm going to create one from scratch. I'm going to call it health services. I'm going to use Node and I'm going to use existing role. This one will be inside my VPC, so I will have execution role. The execution role just gives it certain rights to run. Creating it, let's hope my internet still works. Come on. Yeah, that looks better. So this is the empty implementation. You just define a handler that gets called and you give it a response. So the thing I'm gonna write, let me see. So I already wrote the code for this. Not gonna do too much live coding. And it should be, oh, sorry. So that one is here. Let's drag in. So this is the function. And the way right now, the deployment to Lambda is not ideal. For Python, they do have some libraries that you can actually deploy it right away. But for JavaScript, it's just a matter of zipping it and manually putting it there. So that's what I'm gonna do now. So I have here my index.js, and you can use third-party node libraries. And of course, you don't need to have it all in one file. You can put multiple files. So I'm just gonna compress that, and then I'm gonna upload it. I think it's already, no, this is another one. Then after saving it, you can actually just edit it here. So what this function does, it's calling my function in this library, and this is actually doing a call to my Elasticsearch instance. And the way we've configured it at Nyon is that on all our microservices, the Nginx access files, they're being sent to Elasticsearch. So every log line is going there, which allows us to basically do analytics on that. So what this function is doing for the last 5 minutes, it's checking the average response time per minute to see if it's still healthy. And I've defined here some thresholds. So those are in seconds, which means that if this microservice would have an average and actually 2 data points under 5 seconds, then it would become unhealthy. So I hope that's not too vague. And we can also configure a test event. Or actually, first I need to configure a environment variable. So you can just use environment variables and configure them here. Oh, yeah. I always make the typo. Costing me hours sometimes. Figure out what's going wrong. And we also need to put it inside the VPC, because otherwise it cannot actually access our ES instance. Need to put a security group, because also otherwise it cannot access our instance. Now it should be fine to run. So now we can test it. Doesn't really matter because this one doesn't use input, but this would be optionally your input from your API gateway to the Lambda function. Just going to create that one. Oh. Succeeded. So here we see right now that all the services are healthy. And if I would change the the thresholds here. For example, I set this extremely low, save it, test it. Then you see here that it became unhealthy. So the Lambda function is working. You can also see that this one is slightly different than the JSON we had in our gateway, because here the services are actually the keys, and if you look at the other JSON we had earlier, then you see that we actually had a name key and then the name of the service. So we're going to do some mapping from one JSON to the other. So let me also show you how to do that. So now I'm going to configure, going back to the resource here. And now here I'm going to choose Lambda function. The region is EU Central. And here, I think I called it, yeah, health services. Okay. So if I would do just this, it wouldn't work. And would be interesting to see now what happens. Because that was pretty much the question earlier. And did I deploy it? I think I deployed it. So, okay, so it just proxies, which is a little bit surprising. I thought it would throw an error. But I guess you would be able to set it in such a way that it would behave differently. So, but what I'm going to do, I'm going back into the resource, and then in our integration response. So this is now empty because first it was the mock and it removed that. And here I can paste, let me see which one, that's this one. So that's what I meant with that you can actually put some code in there. So what it's doing, it's taking the input from the response from Lambda, and then it's looping over them and then actually using those keys that you saw and putting them as names. So let's save that, and of course save it here as well. Deploy it, testing. And there we go. So now it has the correct format that our app would expect. And let's refresh, and we got our list. All right, so that's Lambda. Got a few more things. What's also interesting that you can add usage plans and API keys. And so a usage plan would be that you often have with services, like you have a developer's plan, you can only make 1,000 requests per month, or you have a pro plan, you have 1 million requests. So you'd create those different plans, and then you add API keys for each individual, like user or company that would use your API. And I will make those manually now, but like everything in Amazon Web Services, everything can be done with their APIs. Like you can create API gateways with their APIs, you can create Lambda functions, I think, with their APIs, take down services with their APIs. So normally, like through a web interface that the user would be using, then you would create such API keys. But like I said, I'm going to create it manually now. I'm going to create a new one that I will remove afterwards. So here you set the rate basically, so 10 per second, and a total of 100. So they will add up every second, but you cannot spend more than 100 after each other. And also like a limit per month. Let's just add some values here. And then you add a stage. So for us, that would be our testing stage. And if now in our resource we would say that, so that's what we do here in our method request, and actually it added a warning here that this stage is associated with a plan. So here we can now say that you actually need an API key. And then if we deploy it, then you should see an error after a while. There you go, forbidden. That's because we haven't specified the API key and we haven't even created it yet. So let's do that next. Create the API key. Sorry, that's here. Well, actually, you can also do it here. So we'll just oh, need to create one, of course. Go away. So you can specify it customly, but I will just generate one. And here's the API key. So if I also here, this should fail. It's empty now, and you would see an error here. Not doing anything with that at this moment. And to fix it, I'm gonna add a header, which is well, actually I think I defined it here. API key header. And if we go there, so this is the header that we need to specify. And if we now run it, it should work again. There we go. Right, last things. So what else? With the API gateway, I already mentioned proxying to other APIs, third-party APIs, everything. Also, you can add authentication to it. We haven't used ourselves that yet, but you can add all kind of authentication and then also specify Lambda functions to actually do the authentication. You can add VPC links, which allows you to call into your own VPC. And what else does Amazon provide for mobile, especially? Well, a lot. There's the AWS Mobile Hub, Amazon Cognito, which allows you to do user management, device farm for testing, mobile analytics to give you analytics, and AWS just gives you a whole lot of things. I think right now they have like 150 different services or so. So Lambda and API Gateway are just 2 out of those. So it's, well, we enjoy it a lot to use AWS for all our server requirements, basically. So I can recommend that. And that's it. Thanks. Niels?
You mentioned already that you can, like, everything you showed us today, you can do it through APIs and stuff. Is it also possible to, like, make some set of configuration files and then deploy that at once or something like that?
Yes. So your question is if you can make configuration files and then deploy it at once. And if you go to APIs and actually you create a new API, you can import it from Swagger. So then it would create all those things. And also, well, I haven't showed it, but like on all your methods and stuff, you can set things like operation IDs to give your resource and stuff custom names. You can add documentation there. So, and I believe, well, it doesn't support everything that Swagger supports, but a lot of those things, if they are in your Swagger file and you create it from here, then it will be there. But that will only create like the API as it looks like to the client. It doesn't create all the like integrations to the backends. And I don't think that's possible to do that as well.
I think you can with the AWS client.
Yeah, with APIs you can, but I think you'd have to make something for that yourself, because actually I ran into a problem. There's a bug that I had. So I created a VPC link to be able to call our services. And the thing is, if you would configure one of your methods to use the VPC link and then remove that method, then you cannot delete your VPC link anymore, which is costing money, of course, for Amazon. So I had to raise a ticket for that and ask them, like, okay, I get an error when deleting my VPC link, what can I do? They told me, yeah, it's a known bug. The only way you can do it now is to delete your entire API, and then you can delete your VPC link. And they told me, like, yeah, there's no other way to really do it and make it back up or whatever.
Just add the method again and then delete the VPC and then delete the method.
I haven't tried it, but I don't think so. I think they would have told me, or at least that's what I would hope. Yes, another question.
I use the mock functionality and I export it to Swagger. Is the mocking done in the Swagger file, so it's available offline, or do I still have to call?
You would have to call the thing. Yeah, Swagger, as far as I know, doesn't support like mocking. One more question I saw here. No? Yeah?
What made you decide to choose Amazon AWS instead of the other big players out there as you were?
So why did I choose AWS? Well, personally, I started with AWS about 6 years ago, and so that was for like a startup project that I co-founded. There we used it for like almost a year, but then the startup didn't continue. But I learned a lot there. We especially used Elastic Beanstalk there, which is like a service that does load balances automatically for you, auto-scaling automatically for you, and instance management automatically. So you just upload like a WAR file for Java and everything works magically. Didn't use too much else there, and there also wasn't a whole lot there yet. Then I used it again when I was working for NS. They use it there for all their search functionality. So if you use the Reis Planner app and you search for a destination like a town or something, it's using AWS and also Elasticsearch for that. So I used it there a lot. And when I joined last year Nyon, they already were using it. So I didn't have much choice there. But yeah, because I like it a lot and had some experience, we did add like I think 10 or so new services over the last year. We started using Elasticsearch, we started using DynamoDB, API Gateway, you see Lambda, and a bunch of other things. So I never actually tried like the Google stuff or anything else, because this works for me, and like half of the world is using it. So. Any other question? Otherwise, I think we're done. Okay, thanks.